Hello guys, today I'm going to explain the seismic analysis of a building structure. So first let us go to File and New Model. Save. So you can go for Use Built-in Settings with Display Units. Since we are going to work with the Indian standards, I have selected everything Indian. So display units is metric SI. Steel section database is Indian. Steel design code is IS 800. Concrete design code is IS 456. Go for OK. So I'm going to go for a symmetric plan. So the number of grid lines in X direction we will keep 3, in Y 3, spacing 3, 3. Number of stories, let us keep it equal to 3. Story height 3, bottom story height 3. You can go for custom grid spacing, custom story data if the spacing is not uniform and is varying. Then select grid only and go for OK. So you can see this 3D view and the plan story. Now first we will define the section properties. First we will define the material properties. We will add new material. India material type concrete. Let us keep the grade M30. Okay. These are the properties of material grade M30. Then we will go for add new material. We will select rebar Indian and HYST. Okay. Okay. Then we will add the mild steel, mild grade 250. Okay. Okay. So we have added the materials. Now we will go to define section properties, frame sections, and go, this box gets open. Go to add new property, select concrete rectangle concrete, then give, first we will go for a column for a beam property 230 by 300. We will select the material M30, section shape, depth is 300, width is 230. Modify show rebars. We will go for M3 design only since it is beam. Longitudinal bars, confinement bars, and we will keep cover of 25 mm. We'll go for OK. OK. Then we will add a column property. Same procedure. First we will give property name C 300 by 300. Then we will select the material as M30. Then the depth is 300. The width is 300. Modify show rebar. Longitudinal bars HYST 415, confinement bars mild steel, and here the cover is given as 40 mm. We will keep it as 40 mm. Then we will go for OK. OK. Then we will define the slab. So we have taken the beam section as 230 by 300 mm and the column section as 300 by 300 mm. Then these are the minimum dimensions that we usually take, and then we will go for slab section, go to slab 1 and go for modify show property, select the slab material as M30, keep the modeling type same as shell thin and the thickness as 150. Go for OK and OK. Then here change it from one story to all stories. Then go to draw, and we have here draw beam, column, base, object. Go for quick draw beam. Okay, first we will go for quick draw columns. Then the property is this C300 by 300. We will drag a box across the plan, and you can see that these columns are there. Then we will go for draw beam column. We will go for quick draw beam. Then we will go for property as B300 B230 by 300, and we will again drag box. And because of this quick draw property, the you don't have to go to each node and add the property. Now we will go for draw beam column base. No, we will go for draw floor slash wall objects, and we will go for quick draw floor wall. And this is already selected as slab 1. Drag a slab across this, and you can see now we will uh, go for auto draw cladding, use floors, and OK. Yes, so the cladding is gone. Actually, this cladding is used for the wind loads, as the wind pressure will be applied across this cladding. It's not very much used in seismic analysis, but still we would assign the autoclad auto cladding option to the building structure. Now we will move ahead in defining the seismic parameters. First, go to load patterns. Then here, give the name of the load as seismic. Then the type we will select as seismic. Then the auto lateral load. Select the code which you would like to follow. We will go for IS 1893 2016. Add new load. We will go for modify lateral load. So we will consider the seismic load in X and Y direction. Now we will have to feed in certain parameters. So this top story, whatever is there in the building structure which we have modeled, that is present there already. You don't have to do anything. So the response reduction, now we have to put in these values. So the response reduction factor, if you will go to table 7, you will have the response reduction factor R for building systems, and depending on the type of the structural system you have to select R. So we are going for an ordinary RC moment resisting frame, OMRF. So the response reduction factor is R. If you are using the ductile detailing, then it will become 5. So since the building structure we have considered is a simple structure, we will go for response reduction R is equal to 3. Now we will put R is equal to 3. Then we have to put the zone factor. So again we will go to this, and depending on in what region your area in which the, like we have a map which is given in the IS 1893. Sorry, I forgot to mention the code. It is IS 1893 that you have to follow. So there we have a seismic map,